So while we're waiting for the slides to come up, the thing I'm going to dangle as an exciting thing is an interactive demo, okay? Coming towards the end of my presentation. So please wake up and listen and interact with that when we're good to go. This clicker works, I hope. Okay, let's kick it off. Different color scheme, a little bit brighter. I should stay near the microphones. Yeah, so my name's George Nee. I work in a team called Magmo. Most of us are here sitting in that table in the middle. We are a part of Consensus Mesh R&D department, and we're also lucky enough to be funded, with grants from the Filecoin Foundation. And the project we work almost exclusively on is called state channels. And that's what I'm here to talk to you about today. It's going to be a slightly more technical talk than ones we've had before in this track, so hopefully folks can keep up. Please interrupt me with questions as we go through. That will be just fine. So the main takeaway for today is that it's been said before, and I think Patrick did a great job of setting the landscape earlier today, but we want some guarantees or assurances about retrievability in Filecoin, and we believe that directly paid retrievals, if the payments are low cost and low friction, can be an important part of the solution to that puzzle. And maybe complementing some of the other mechanisms we've seen, based on reputation and testing and so on. And at Magmo, we're building the tech to make that happen. And I'm going to tell you all about it, but before I do that, I'm going to tell you a story, a saga about decentralized payments and the history of the tech that's brought us to this point. So almost exactly 15 years ago, we had the Bitcoin white paper. And as you all know, this is the origin of many powerful ideas around decentralized money, self-custody, all those great things. And since those early days, scalability has always been a concern. And that's the kind of angle that we're coming at it from. So on-chain payments, using something like Bitcoin, you can send your transactions there. It's a permissionless system. It's brilliant. We all love it. But we know that there are downsides. It's slow and it's expensive. And I've put some typical block times up there. If you really want finality for your payment, that means you're very sure it's not going to just disappear. You've got to wait for a multiple of these block times. So it's very slow for certain applications. And you've got to pay fees to make the whole system work. And that's not so great. And the main problem is the limited throughput. So blockchains can do, a handful, maybe a dozen of transactions per second. So that's going to be no good for a really high-performance payment system. But then we have Bitcoin Lightning, which is a network built on top of Bitcoin. And it's really great. And what we're doing is very similar to Lightning, but with some extra special sauce that makes it even nicer. And Lightning is a network of payment channels, and I'm going to break that down and explain it to you in case you're not familiar. So with the payment channel, instead of launching payments, sending payments by launching transactions straight to the blockchain and having those, broadcast publicly to everybody and verified by the entire network, what you do instead is you essentially lock up a slightly larger amount of money in escrow on the blockchain, and then you send payments with a channel. You send payments directly to the person that you want to pay, and you gradually release that money you've locked up by sending more and more signed messages, which constitute payment channel updates, or just payments, we can call them that. And if you look in the Filecoin spec, you'll see the system that Hannah built, because she seems to have built almost everything. They're called vouchers in the Filecoin world, and that's something that we've carried through into our implementation. This is great. We're reducing the cost, we're reducing the latency. The great thing about it is you get very, very fast finality, almost instant. So as soon as that provider in this sequence diagram receives the payment from the payer, they've effectively got finality instantly. They don't have to wait and see if that payment disappears. They've got it. They know they can claim it later. They're good to go. They can release whatever service they might want to gate behind that payment as soon as they get the payment, which is a really important feature. This is not the end of the story, because there's still a lot of pain here. If that client wants to connect to a different provider, they're going to have to go on chain again. And Patrick explained this really well earlier. You're still going to have a lot of channels, a lot of transactions going on chain if you just stick to these plain old payment channels. And what you do in Lightning is you build up a network. And the network might look something a bit like this. It's obviously more complicated, but we have nodes in green, and we have payment channels in purple. And I'm going to call them ledger channels now, for reasons that will come clear. So a blockchain is a ledger. There's accounts, there's balances. A payment channel, a connection between nodes backed by an on-chain deposit, is also a ledger. It's just a kind of two-party ledger with two balances, one for each end of that link, of that purple link. And that's a powerful way to think about them. And what we can do once we have this network set up is we can reuse existing connections so that people who aren't directly connected can still route payments to each other. So we just need a way of atomically linking various payments in this network together to effectively have these multi-hop payments going around. And that's really the situation you want to be in. So the sequence diagram now looks a little bit like this. The payer doesn't connect directly to the provider, but connects to an intermediary node. So this is a service provided perhaps by a special purpose business who want to run the service of intermediating payments. And that might be a kind of hub and spoke kind of topology where they're sitting in the middle, or it might be a bit more like a mesh, which is what Lightning Network is a bit more like. And it might just be someone who's been found through some kind of pathfinding algorithm. And the client or the payer and the provider both have a connection to this intermediary setup. And they do that with the slow and expensive blockchain transactions, but that is something that's quite infrequent. And once that's happened, we can atomically, if we have the right mechanisms, we can make the payment from the client to the intermediary and another payment from the intermediary to the provider, and we can do those two things atomically. So that in the end, the intermediary is kind of value neutral. They might have gained one coin and lost one coin. Perhaps they've creamed off a little bit of a fee as that goes through. And the client has lost a coin and the provider's gained a coin. So it's a net payment that works just fine. And the way this is implemented in Lightning is with something called a hash and a time lock. The actual terminology you'll find in the literature is called an HTLC. But you can think about it as a hash and time lock. So I'll explain a bit more how that works in a minute, but that's the mechanism that ensures the atomicity, the coupling of the two payments. And a great stat about Lightning is that it currently locks up the equivalent of over $100 million. So it's quite a good success story in the payment channel landscape, and it's one that we would like to emulate if we can. I think it's quite encouraging. Now, there are some limitations to Lightning, and that's kind of where our tech comes in, and that's what I want to explain to you. So here's a picture in a bit more detail about what those coupled payments look like in Lightning. But I've shown more intermediaries now. So this is a 3-hop payment between the client and the provider. There are 3 nodes in the path between them. And we're going to assume they're already connected with those ledger channel connections, and they want to set up one of these multi-hop payments. What you can see is this kind of staggered blocking protocol, if you like, that has to take place in order for that multi-hop payment to work. And what that means is intermediary 1 won't set up the payment to intermediary 2 in the chain until they've seen that the payment that's coming into them has already been set up. So each link in the chain has to wait for the previous one, and that will slow the whole thing down. So it's not terribly good scaling with the number of hops in the network in terms of the time it takes to complete the payment. That's the first thing. The other thing is, I mentioned it's a hash and time lock. So how that works is each payment is a conditional payment. And what the rules of that payment are in that ledger channel are saying, I will pay you so many coins if you reveal a secret pre-image to a certain hash before a certain deadline. And all of those HTLC, hash and time locked payments get set up, and then they all get unzipped at the same time with the same secret pre-image that's revealed at the end. And that's the thing that makes them all couple together and be atomic. And I've written there the timeouts that need to be put into this system to make it safe. And what you'll notice is that as you go from right to left, I've got a T and a 2T and a 3T. Effectively, the timeouts need to be staggered as well to prevent a timing attack on this system where you try and break the atomicity by firing in sort of blockchain transactions at well-timed moments. And the way to protect against that in Lightning with these hash and time locks is to increase the timeout on those payments as you go back. So again, it's something that scales with the number of hops. The amount of time your money will be locked up as an intermediary or as a payer is going to increase when that chain is longer and longer. So that's not terribly great scaling. The other problems with Lightning are kind of maybe more difficult to solve. What I just mentioned has been addressed in the literature, and I'll put some links up there. But things like, obviously being locked into the Bitcoin currency is something that's much more difficult for Lightning to solve, and that's something that we can address with what we're doing. And the other really important thing I'd like to stress is that if the payer wants to pay the same provider multiple times, over and over and over and over, then every intermediary in the chain has to process every single payment, and they have to do essentially some cryptography on every single one of those transactions. So that's not terribly good either, and that we think would negatively impact the performance of a payment channel network built on this tech. So we need something better. So many of Lightning's limitations, as great as it is, stem from the constrained programmability of Bitcoin. And by leveraging the Ethereum Virtual Machine, which as we all know is now available through the FEVM, we have the chance to build something technologically superior. And that's what we think we've done. And it's called Nitro Protocol. And it's got lots of nice features, we think. And these are just some of them. The first one that maybe a lot of people don't realize in the Filecoin ecosystem is that they're called state channels. And that's, as I mentioned in the first slide, that's the project name, but it's also the name of the technology. And a state channel is something a bit more than a payment channel. You can use it for much more than just sending money to people. You can send conditional payments. You can run arbitrary state machines inside a state channel. That enables you to do things like games, play chess in a state channel, play poker in a state channel. Or you can make payments conditional on cryptographic proofs, for example, which could be super interesting when we're talking about content addressed file retrievals. So that's something I'd love to talk about later. We can support other kinds of currencies, obviously native EVM tokens like fill tokens, ERC20 type tokens. We can go across multiple chains, especially if they're EVM compatible. And that means we can deploy on things like rollup to get a kind of double scaling effect where we've got the sweetness of state channels, and even the state channel deposit transactions have a lower cost and a higher throughput. And as I mentioned, in terms of the advantages over Lightning, we can do constant time multi-hop payments, and they can be disputed, recovered from if things go wrong, in constant time too. And we're highly gas optimized as well, which is great. The final thing I think could be really key to thinking about how what we're doing relates to retrieval incentives is that state channels and payment channels, especially multi-hop ones, they have really good privacy properties actually. So the idea is to take all of those payment transactions off-chain. So they become something that used to be public and they become private information. And because we have this extra layer of abstraction, which I'm going to explain in a minute, you won't even know who's connecting to who in a payment system like ours, which is very powerful, I think. If you want more information about what we're doing and my talk doesn't make any sense, you can go to our website, statechannels.org. You'll find their research papers going back to 2018, where we've been thinking really hard about this stuff. There are blog posts, POCs. The main thing we work on, though, is our implementations. So we have on and off-chain components. The on-chain components are written in Solidity, and they are deployed to the calibration testnet as of a couple of weeks ago, which is great. And the off-chain component is a state channel node implementation, which we call Go Nitro. And that is running all of the off-chain protocols to make all this stuff happen. So I want to introduce you to one more concept now. We talked about a payment channel network and purple links between nodes, which I was calling ledger channels, because not only are they supported by deposits on a blockchain, but they are like little mini ledgers themselves. And that property enables us to think of a really powerful abstraction, which is quite unique to our state channel protocol, which is called a virtual channel. So instead of simply kind of linking payments in those existing ledger channels, what we do is we create a brand new channel that looks almost exactly like a channel that's funded from the blockchain, but isn't. It's funded from those existing channels. So we have like another layer of abstraction now. The blockchain provides the money in escrow for the purple ledger channels, and the ledger channels provide the money in escrow for the orange virtual channel. And that's a super powerful abstraction because you can take one of these programmable channels that's running a complicated application like chess or something like that, or like some kind of Filecoin specific application perhaps, and you can treat it as if it's funded on the blockchain, where in fact it never touches the blockchain. It's only funded entirely off-chain and defunded off-chain. So what would a multi-hop payment look like in that picture? I've talked about the programmability of state channels, which is really powerful. But what we're actually going to do is come back to payments and use the extra power of the EVM to just make the payments as good as we can make them. This is a really horribly complicated sequence diagram, which I don't want you to look at too carefully unless you're super interested. But it's how we do multi-hop payments in our system. Let me show you the simplified version, which looks like this. So what I'm trying to emphasize here is that we have some pre-existing connections in the network. That's our starting point. There is a path from the client to the provider through those existing connections. Here it's a 3-hop route. It could be more, it could be less. And we have something called the virtual fund protocol, which we run, which involves all of those nodes working together to send various signed messages around, and it takes constant time. So the latency for that to complete doesn't depend on the number of chains in the links in the chain, which is really good. And similarly for when we defund it. And as I mentioned before, the really powerful bit is that once that's happened, the payments can go directly from the client to the provider without passing through any of the intermediaries. So there's no computational load on them once they've helped set up the situation. And this works great if you want to do things like micropayments, which I'm going to get onto in a minute. Another really cool thing about the fact that it goes directly from client to provider, this may be not quite so relevant to Filecoin, but you can use any transport for that. So you could use something like near-field communication for that. You could build it into a credit card and you could go boop, and the information doesn't go through some network to send that payment. It goes directly from the payer to the payee. And that's just a really powerful fact. So I mentioned our Go Nitro nodes, and I just wanted to share, this is a dev summit. I want to share what the API, what the interface of those nodes is. And we try to keep it pretty simple. So what can you do with your node? You can create a ledger channel by passing in a particular counterparty you'd like to connect with and some specification of the amount of money you want to lock up. And you can close that ledger channel and get your money back and make it liquid to use for something else. Once you've done creating the ledger channel, you can create a virtual channel with that pre-existing connection, and you get an ID for that. And again, you can close it down, of course, but if you keep it open, you can make payments using the Pay API. So we try to make it as simple as possible. And this is code that can be used as library code, and that's how we started developing it, because we wanted to integrate it into things like Lotus or Boost. But more recently, we've developed it into a standalone process that you can drive over JSON RPC effectively. And that's been really powerful and a great boon for us. We have a Go JSON RPC client, and we have a TypeScript RPC client, meaning that you can interface with this stuff from the browser, which is what our demo does. So I'd love to share that with you now, and hopefully it will spur on some really interesting conversations. So if anyone's fallen asleep, now's the time to wake up because it's demo time. I'm going to walk you through it. Here we go. So let's imagine we've got the same scenario I've been talking about all day. We've got the client and the provider. It's a storage provider. It's a retrieval provider. It's a retrieval client, okay? And for this demo, we partnered with Decent Data Center. So we're very happy that they're joining us with this demonstration. And what they've done is they've done some storage deals with us, and we've stored some cool images on their SP node, okay, which is running Boost to HTTP. And what the demo is going to be showing you is how you can do a paid retrieval for those cool images, okay? So between the client and the provider, it's like an adventure story. There are things in the way that you've got to get through. So what have we placed in way? We've placed a small Nitro network of 3 nodes, okay? And we've placed a proxy server. So the proxy server, we're hosting it, but if you like, it represents Decent and their interests. And I'll explain that again in a minute in more detail. In the blue section, we have 3 nodes. They're the 3 nodes I've been talking about all day. The payee node, again, represents the interests of Decent and the storage provider on the right-hand side. It's going to be collecting payments for them. The payer node is going to be accessed through the browser in the demo, so you're going to have fun with that. The intermediary node is just sitting there in the cloud and is providing the intermediating service. We could have had more, we could have had less, but we just wanted to show you the power of the protocol, so we put 3 up there. And what we've done, I mentioned we've deployed our system on calibration net. We've gone ahead and set up those ledger channel connections for you already, just to make the demo a bit more exciting, and you don't have to wait like a long time for your deposits to be confirmed, or you don't even need a Filecoin wallet to try this stuff out. So that's the entry point. I hope that makes sense. If anyone wants to try this stuff out, you can get your phone out now and go to demo.statechannels.org, and you should see something a bit like this. And I'm going to walk you through how it works. You can also do it on your browser, of course, if you've got your laptop open. So, as I mentioned, the network's been prepared, and we're inviting you as a user to effectively join the network. And what you do when you hit that OK button is you're connecting to the payer Nitro node in the cloud that we've provisioned for you. Once you've done that, you're invited to connect to the Decent system and create a virtual channel, which, as I've explained, is using those pre-existing ledger channel connections to entirely off-chain and pretty rapidly set up a payment channel with the retrieval provider. So when you hit that button, it executes the protocol that I talked about up there in the cloud, and you see your balances appear now. So we've got 2 progress bars showing the balance in picofill, I think it is. This is test fill, it's on calibration net. So the user has a lot, the provider has none at this point. And we can select one of the 3 cool images to download and hit the pay and download button. And the following things will happen when we click that. We will reach out to our Nitro node in the cloud and ask for it to generate a payment, which is just a voucher. It's just some bytes, it's a digital signature, and we'll get that back inside our browser session. We'll then attach that voucher to an HTTP request for that file and send it off to Decent. Now, it doesn't go directly to the SP. It goes to our proxy, which I promised that I would explain how that works. And what the proxy does is it intercepts the request, it knows how to validate the payment voucher, it checks with the Nitro network that it is a legit payment, and if it is, it passes the request on to the origin server, to the Decent storage provider, and returns the file. If the proxy decides that the payment is not good, it does not return the file. It returns a 402 HTTP code, which means payment required, which is something that's already in like the HTTP spec. So we're just reusing existing stuff there, which is pretty cool. So let's click the button. The balance decreases, and we see this cool AI-generated art, which is just there for demo purposes to make it interesting. It could be any kind of data, of course. So we think that's pretty cool. I encourage you to play around with this thing. We were quite keen on this this architecture of using a reverse proxy there, and it was Dirk, I think, from the from the Bedrock team who gave us the idea to work on that. And it's got really great advantages. It means that storage providers actually don't need to understand Nitro protocol at all to integrate our system. All they need to do is stand up one of these proxies, maybe add it to an allow list, and like if they want to, they can block other traffic, and all of a sudden paid retrievals become an option for them. So that's pretty exciting. Our demo has some advanced features. So you can try turning the payments off, and you'll see that things don't work, which is what we want you to see. And the other one is you can click the slider to enable micropayments. And what that's doing is it's not paying upfront for the entire file, which is what just happened when I showed you. It's paying for 300 kilobyte chunk of that file, and then holding the rest of the money back until it's been delivered, and then repeating the process until the entire file has been delivered. We call that micropayments. You might call it a gradual fair exchange protocol. I think Patrick used a slightly different terminology for it earlier. Optimistic fair exchange, I think. We've written kind of extensively about why we think that's quite a powerful abstraction with this blog post, so please check that out if you want more details. But I would love some feedback and to hear what people think of that mechanism too. Under the hood in our demo, it uses HTTP range requests to implement that. That's the end of what I have to say so far. I'll just end with some pointers on what we've done and what we're going to do. So, as I mentioned, Nitro as a service, or RPC enabled Nitro, is something we've done quite recently that's gone really well. We have a fully decentralized messaging system based on libp2p and distributed hash table. The virtual channels over multiple hops is something that's working really well. Work we've still got to do is things like automatic pathfinding, automatic recovery from offline peers. At the moment, you can technically recover from those kind of situations, but it's a very manual process, and we want to make it automatic. And things like self-custody. We cut some corners to make this demo accessible. In order to make this a true kind of decentralized, trustless system, you're going to have to run your own Nitro node. That could be something that you run as a system process. It could be something that's like running the cloud if you want to do it that way. Or it could be something that actually runs natively inside the browser. If that's something that there's a lot of demand for, that's definitely something we can build. Payment fee mechanisms is another kind of research topic for us. We have some basic stuff worked out, but we'd like to push that out into this demo and beyond. And yeah, I mentioned browser node already. So that's the end of my talk. Love any questions. And yeah, thanks for listening.